Hey everybody, welcome to part 2. We're going to pick up where we left off and we're going to be talking about Punnett squares. And we're going to look at pedigrees. All right, jumping into pedigrees. So let's talk about autosomal dominant versus autosomal recessive. Genetic disorders or traits, because it could just be a general trait like eye color or anything that's controlled by one single gene. If it's autosomal dominant, if a trait is autosomal dominant, that means a person can either have two genes for it to have it or can have inherited one gene from one parent and the recessive version from another parent. So it means there's two ways to inherit it. It also means that a person who has the allele for the dominant version of the trait is going to have that trait. They cannot be a carrier of the trait. They either have it or they don't. So for an autosomal trait, that means it's a trait that's carried on chromosome pairs 1 through 22, the ones that code for a body. Remember, pair 23 is our XX or XY, which is our biological sex chromosomes. Okay, the important thing for autosomal dominant is if I'm tracking it, if I'm looking at a pedigree and I'm tracking an autosomal dominant, and I know I'm already told that it is, the shaded in boxes would represent people who have the dominant trait. That means that people with the unshaded boxes would have the recessive trait. This is really important. Whenever I'm figuring out pedigrees, I always start with the group of recessive traits. Whether they're the shaded group or the unshaded group, I'm always going to start with the recessive because there is only one combination of alleles that gives me the recessive trait, and that would be two recessive alleles. If I'm using, let's say, the lowercase a's, capital A, lowercase a. So if I'm filling out my pedigree and I'm trying to figure out the genotype and who has what and what's going on, if I'm told that it's a dominant trait, I'm not going to start with the shaded boxes because there's two different possibilities for each of those. I'm going to start with the unshaded boxes. The unshaded boxes are the people with recessive trait if it's dominant. Something really cool with people with recessive traits. In order to get a recessive trait, you have to have inherited allele from mom and from dad. That means that mom and dad either have the trait or are carriers for the trait. This shows up in this pedigree in two different places. If we look at person number 7, they're the third child of person 1 and 2. They don't have this dominant trait, means they have the recessive trait. Because they have the recessive version of the trait, if I look at their parents 1 and 2, now their parents have the dominant trait, but they have to have passed it. The recessives both have to pass recessive onto their child. That means I know that for person 7, their parents are both carriers. If I look at person 8, they have the recessive version of the trait. Mom also has a recessive version. So again, parent can either have it or person number 4, we know that their dad also has to be a carrier because they only get one from mom. Even though mom has both recessives, mom only passes on one. Remember back in that video, part 1, we talked about meiosis. Got one from mom and they got one from dad. So we know that dad is a carrier. It also works the other way down to children. If a person has it, their children, we're talking about recessive version of a trait, if the parent has a recessive trait, their children also are going to have the recessive trait. If they got one from the recessive parent and one from the carrier other parent, or so they're either going to have the recessive trait or they will also be carriers of that trait. For example, blue eyes is recessive. I have blue eyes. My daughters have brown eyes. Now they inherited a brown eye allele from their dad, but they are carriers for blue eyes. Okay, so they have it. In this case, I know that person number 9, because mom has a recessive version of the trait. We know number 9, because we're tracking a dominant trait, has the dominant trait. So would be capital A, but because mom has it, is a carrier. So also would be big A, little a. It's really important that if two people with recessive traits have offspring, all of their offspring are going to have that recessive trait. For example, my mom and dad both have blue eyes. All of their children have blue eyes. My parents only have the recessive alleles. There's nothing else to be passed on. How do we know something is autosomal dominant or recessive? We're going to look at that in the next slide. In this case, we're tracking autosomal recessive. So in this case, we're going to flip it. In this case, it's the shaded boxes that have the recessive trait. And so I would give those right away 2 lowercase letters. I would go up to their parents, and I would mark their parents as either having it if their boxes are shaded too, or as carriers. So for example, person number 10 has it. I would mark that their mother also has it, so she would have the 2 lowercase letters, but I would mark dad as a carrier, capital letter, lowercase letter. Same thing with person number 13. I would mark their parents. Person number 17, I would mark their parents as carriers. And then I would go the opposite way as well. I would look at anybody who has the recessive trait, and I will mark all of their children as carriers. So person 1, I would mark 6, 7, and 8 as carriers. For person 4, I would mark 9 and 10 as carriers because we already know number 10 has it. And for number 17, I would mark their parents as carriers as well. How do we know? So how can we look at a pedigree if we're not told it's recessive or dominant and know if it is or not? It's all if it hides. I look here and I see the person 17 has this trait, but their parents don't. That means it hid in their parents. That means that this is a trait that can hide behind another trait. It means it's recessive. So I know that having this trait is a recessive trait. If I go back to the dominant one, notice that there's nobody who has it who doesn't have at least a parent who has it as well. These are both, and for both of these are autosomal. So equal occurring in male-female has nothing to do with it. X-linked recessive inheritance, a little bit different. For an X-linked trait, males who have X and Y only have to inherit one allele to have to get this recessive trait. Females, being XX, have to inherit both. For X-linked traits, they are far more common in males than females because males only have to get one allele in order to have it. Duchenne's muscular dystrophy, hemophilia, and color blindness, and male pattern baldness are 4 traits that are X-linked traits. So there's some other pieces. How do we know by looking at a pedigree if something's X-linked or not? 1, we're going to look to see if there's more males than females that have it. In this case, we have 5 males versus 3 females. It's not very helpful here, but for a female to have it, so we can look at for a female to have it, here's how we know if it's X-linked or not. For a female to have it, she has to have inherited it from both mom and from dad. So any female, we look at the pedigree. If it's mostly males, but there is a female who has it, we go to their father. If their father has it, and in every case in the pedigree that's the case, then we know we're X-linked. If I look here, person 1, mom happens to have 2 recessive alleles, and dad doesn't have it. In this case, the male children have it. Dad passes on the normal trait to the females, the dominant version of the allele. The mom passes on a recessive. Now, her daughters are carriers, but they don't have it. But the sons who only get their X chromosome from mom, they don't get one from dad, because then they would be female, they have it. So this is what we're going to look for. If we're looking for males who have it, and if a female so it's going to be mostly males, and if a female has it, then her dad also has to have it because he has to pass the X on to the daughter. The daughter's XX. Again, X-linked recessive traits. Either it is passed on the X chromosome and the child also inherits a Y, so X and Y for male, or for XX for females, has to inherit one from mom and from dad. Because they have to inherit both, it's much less common. So how do we know if a mutation is hereditary and not a random mutation? There's a lot of conversation around this when it comes to different diseases, different cognitive diseases. Scientists and neuroscientists have been doing a lot of this when it comes to things like anxiety and depression and ADHD and learning disabilities and autism. That's really where a lot of this conversation is happening right now. So, how do scientists know if they're trying to figure something out? If it's just like something that randomly happens, how do they know? Family history. Scientists study family history, and if they look for a gene that's different, and if this different gene exists in the family history of other people with the same disease or disorder or just different trait, then it's hereditary. Well, what if you're the first? Somebody in every mutation, in every difference, was the first. Well, in that case, you would look at their offspring. You would look to see, does this pass down, to know if it is hereditary or not. Right? Thank you so much. Hope you guys do well.